RAM, aka memory, is the temporary storage where programs run on your system. So when we're talking about processing a program, programs come off of your hard drive while they're running, they're sitting here on RAM, and then they're being processed through the CPU itself. Any return data comes back to RAM, and it isn't until you hit File Save that the data actually goes from RAM back to the hard drive. RAM's important. Today's systems need somewhere in the area, what depends on your CPU and your operating system, but you'll see anything from as low as half a gigabyte to 8 to 16 gigabytes on today's system. Keep in mind it can be more or less than that, but that's the main group of people right there. So when we talk about RAM, there are two big things we discuss more than anything else. We discuss capacity, how much RAM is in my hand, and we talk about speed. How fast is this RAM? So when we hold an individual stick of RAM, and that's the term we want to use, I have a stick of RAM in my hand, we have to be able to recognize those two important features. So the easiest way to do that is to look at a label. Now, but before we do that, what I want to do is talk about the different types of RAM that have been developed over the years. The first type of RAM that we've ever used in computers was known as DRAM, and actually we still use DRAM to this day. DRAM simply means that every bit is stored with a little capacitor and a little transistor. DRAM has been improved dramatically over the last 30 years, but we still use it today. There's been a number of changes of that DRAM, and the CompTIA exams harp on your ability to recognize, count the number of pins, know the numbering schemes, all kinds of stuff when it comes to DRAM. So let's do a little march of DRAM from about 1990 till today. What you're seeing right here are 4 different types of DRAM that have been used over the years. What I want to do is start off with this guy right here. This is called SDRAM. SDRAM is distinct because it has a 168-pin DIMM, dual inline memory module. Also notice that it's got 2 notches in it. Only SDRAM has this. They call it DIMM because you'll see these little pins here and these little pins here have different jobs. They might be at the same location, but they have completely different jobs. And that's SDRAM. SDRAM supplanted a lot of much older RAMs. I'll just call them the RAMs of your forefathers. They were DRAM, but the S in DRAM stands for synchronous. That means it was synchronized to the system clock. Previous to this, we had ancient RAMs with names like fast page mode and EDO and crazy RAM like this, that you had to do some really bizarre things to make it work. And it's not on the A+, thank goodness. So synchronous DRAM has a clock speed, just like a CPU has a clock speed. So it was important that you got the right speed for your motherboard. As a result of this, Intel and a few other companies got together and created speed ratings for RAM. And they had names, and they would be called, for example, if you had a 66 megahertz motherboard, it would be called PC66. Or if you had a 100 megahertz motherboard, it would be called PC100. Certain motherboards required certain speeds of SDRAM, and you had to get the right stuff. So your PC ratings made life a lot easier. So SDRAM lasted for quite a long time. In fact, you'll still see SDRAM out there. Not in PCs so much, but in other equipment, oil field logging trucks, all kinds of crazy things, printers. You'd be amazed where SDRAM still pops up. SDRAM was fantastic, but people wanted faster. And the problem was it was very difficult because if you're going off the speed of the motherboard, how do you make your RAM faster? So they did something kind of like they did with CPUs, and they created something called dual data rate or double data rate SDRAM. So DDR SDRAM, I got a piece of it right here. Right here is a piece of DDR SDRAM. Now this is pretty standard stuff. First of all, that metal cover, that's more marketing than anything else. It was designed for dissipating heat. This is a 184-pin DIMM package. You notice that I give you all these DIMM package sizes? That's because they're important for the exam, okay? Now compare the DDR RAM to the SDRAM. If you take a close look, even though they're physically about the same size, the SDRAM has 2 notches, whereas the DDR has a single notch. DDR SDRAM stood for Double Data Rate SDRAM. DDR RAM was pretty cool because it took the motherboard speed itself and then in essence doubled it so that for every click of the clock on the system clock, you got 2 RAM clocks. So it was a way to speed up RAM without having to have faster motherboards. DDR, well, it changed things a little bit because we couldn't just use a regular PC rating for it, because in essence we've got 2 speeds. We've got the DDR speed, and then we have the PC speed. So to make all this work, basically you do this. You take the motherboard speed, whatever that might be, let's say it's 100 megahertz, and then you double that, and that's your DDR speed. So now keep in mind, that's going to be written on the stick itself. This isn't something you're going to have to calculate. But you then take the DDR speed, which in this case is 200, and you multiply it times, ready, 8. So take the DDR speed times 8, so DDR2 times 8 equals PC 1600. So remember how to do that. You will see that on the exam. Now keep in mind, it's easy to tell SDRAM from DDR-RAM simply because the PC numbers for SDRAM are just double or triple digits. PC 66, PC 100, whereas with DDR, it's always going to be 4 digits. The last generations of DDR were getting up in the DDR 400 range, which would make them PC 3200. Look how quickly I can calculate times 8. So DDR was great, but then something else came along because we wanted even more speed, and that was DDR2. This is a stick of DDR2. Now I want you to compare that to the SD and the DDR. This is a 240 pin DIMM. And again, while the size looks very, very similar, in this case, even though they both have 1 notch, notice that the notches are in different places. You cannot accidentally put DDR2 RAM into a motherboard that's designed just to take DDR. So 240 pin DIMMs, notch in a slightly different place. So now with DDR2, the speeds even get a little bit more complicated. DDR2 did still double pump like DDR did, but it also threw in a clock doubling. So now we have to do we got to double the double. So you take the motherboard speed, let's go in this example and say it's 100 megahertz, and you double that, so that gets you your DDR speed, which would be 200 megahertz. But then to get the speed of the DDR2, you've got to double that again to 400 megahertz. And literally you would see on the stick itself, it would say DDR2 400, for example. Now to get the PC speed, multiply that times 8. You always multiply times 8. And the PC value is going to be, and we write a 2 in, so it's going to be PC2 3200. There have been a lot of different speeds of DDR2 over the years, so make sure you can look at either a DDR rating or a PC rating, and because of its nomenclature, recognize, that's DDR2, and also to be able to generate a PC rating yourself, and remember, just multiply times 8. It's not that hard. So you think they could leave well enough alone, but they didn't, because today, the most common form of DDR that we see out there is DDR3, and yep, I got a stick of it right here to show you. Now this is a stick of DDR3. And it's got a cool little cooling fin on it there. That's just to impress people. This is also a 240 pin DIMM. So DDR2 and DDR3 have the same pin count, but look where the slots are. Again, there is no way to accidentally put DDR3 into a DDR2 motherboard or vice versa. You're fine either way. DDR3 achieves its lofty speed by quadrupling the bus. So let's go through all the math one more time. CompTIA loves to do this, and so do you. So let's say we've got a 100 megahertz motherboard. We take the 100 megahertz and we multiply it times 4 to get our quadrupled speed. So we go from 100 megahertz to 400 megahertz. And now to get the DDR3 speed, we got to double that to 800 megahertz. So, and it's literally written out, DDR3 800. So then we go ahead and take that times 8, and now we get a PC3 6400 speed. It's really, really important that you can look at these speeds. When you're buying RAM, you don't go up to people and go, you know, how fast is your CPU? They need to know how fast your motherboard is and what type of DDR it needs. So you need to be able to take a look at any DDR value and convert it into a PC value, not only so you can pass the questions on the CompTIA A+ exam, but so you don't look silly in front of salespeople who are trying to sell you a couple of sticks of RAM.